We're asked to evaluate the argument if P then Q, not Q, therefore not P. Now, if we know our basic arguments, this is one of them, okay? Could it be modus ponens, modus tollens? What could it be? And this is one of our standard arguments, okay? We want to verify this argument, and first we want to show that this argument is equivalent to this statement here. Well, the argument says that if both of these things are true, then this thing is true. Okay, well, if we write that out in words, it means that if both P and Q and not Q are true, because that would be our two premises, if our two premises are true, then our conclusion is true, our conclusion being not P. Well, that's the same as saying that if this, which is this, and this, which is the same, if this whole statement is true, then this statement, not P, has to be true, which then is the same in turn as this statement here. If this, if this, then this, then this. So if this, then this. Now, we test this with a truth table. We start by writing our PQ values, and then we write down the thing that we're trying to evaluate. We look at what it is we're trying to evaluate, and we ask ourselves, what two columns would I have to look at? What would be the headings of the two columns I'd have to look at in order to evaluate this conditional? Because this statement ultimately is, if it's a conditional with this antecedent and this consequent. Okay, well, we need a table, we need a column of the table for our antecedent. Well, I've written that here. So I've just rewritten this here, and I've underlined it in blue just like I underlined this in blue to show that this is one of the two columns we need to look at in order to evaluate this condition. And the other column, of course, is our not P column. So we have our antecedent here and our consequent here. Okay, well, what do we need to look at in order to evaluate this? This is an and statement between this and this. Okay, in other words, it's if P then Q and not Q. To evaluate this, we need columns for if P then Q, so I put one here, and for not Q, and I put one here. Now, none of these truth values are at this point filled in, but we fill them in the most straightforward possible manner. To evaluate not Q, all we have to do is look back at Q, and we reverse the truth values of Q, and you can see that that's been done. And then if P then Q, what's the rule? Unless P is true and Q is false, if P then Q is true. The only way it can be false is for P to be true, Q to be false. That's the rule. So, that occurs here. The antecedent is true, the consequent is false in this row and only in this row, so that this conditional is false here, but it's true every place else. And you can check out that. You can check that out in detail. Okay. Now we evaluate not P just by reversing the truth values of P, and you would do this. Check it out yourself. Okay, then we would have this. Now, in order to evaluate this, we have the antecedent, if P then Q, right here. That's not, actually it's not an antecedent. We have two statements, if P then Q here, not Q here. We're evaluating a conjunction. So both of these have to be true in order to make this statement true. And that occurs only here. This statement and this statement are true in the fourth row. In every other row we have a false under one statement or the other. So that this column is evaluated as we see it. False here, here, and here. True in this one case where it's true. Now we evaluate the argument. The argument is evaluated. The argument is a conditional. It's true unless you have a true for the antecedent and a false for the consequent. Well, the antecedent is here, the consequent is here. In both of these cases we have false in for the antecedent so that the conditional is true, because we don't have true, false, we have false, and then it doesn't matter what we have. We have to have a true here to say that this is false. We don't have true, it's true. Okay, we don't have true here either. So the antecedent is false in all three of these cases. Now it is true in this case, so we have to check and see if the consequent is also true. And it is, so we have another true. So that means all these are true, the argument is valid, and we could also say that our statement is a tautology. Okay, now we have another argument for the next problem, and we'll take a look at that.